Hello everyone, welcome back to my channel Explain Maths. In this video, I will be solving exercise 9.3 of the chapter Mensuration. Question number 1. Given a cylindrical tank, in which situation will you find surface area and in which situation volume? To find how much it can hold. So how much it can hold, that will depend on the capacity of the tank, right? So in this case, you have to find the volume. Number of cement bags required to plaster it. Now to plaster a cylindrical tank, you are going to plaster on the surface area of the tank, right? So in this case, you have to find the surface area. Now to find the number of smaller tanks that can be filled with water from it. So in this case also you have to find the volume because it is asking what is the number of tanks that can be filled. So in this case also you have to find the volume. Now question number 2. Diameter of cylinder A is 7 cm, height is 14. Diameter of cylinder B is 14 and height is 7. Without doing any calculation, can you suggest whose volume is greater? So according to me, cylinder B will have greater volume because if you see here, the diameter is bigger than the diameter of cylinder A. So this is my guess, like volume of cylinder B will be greater as it has greater radius. Now we have to verify it by finding the volume of both the cylinders. So in the first case, radius of the cylinder is 7 by 2 because diameter is 7 centimeter, height is 14 centimeter. So volume of the cylinder formula is pi r square h, right? Now I'm going to put all the values over here. So we know that the value of pi is 22 by 7. So I can write here as 22 by 7. Radius is 7 by 2. So 7 by 2 into 7 by 2 and height is 14. Now I am going to reduce it. So 7 times 1, 7 times 2 and again 2 times 1, 2 times 1, 2 times 1 and here 2 times 11. So I am going to get from here 77 into 7 and if I multiply it, I will get 539 centimeter cube. So this is the volume of cylinder A. Now let's find the volume of cylinder B. So radius of the cylinder B is given as, it will be 7 because diameter is 14. So radius is half of the diameter. Height is 7 centimeter. Now again volume of the cylinder formula I am going to use, which is pi r square h. So pi value is 22 by 7, radius is 7 and height is also 7. So I'm going to simplify it. So it is 22 into 49 and from here I can get, if I multiply it, I will get 1078 centimeter cube. So from here I can see that volume of cylinder B is greater, right? Because cylinder B volume is 1078 and cylinder A is 539. So volume of cylinder B is greater than the volume of cylinder A. Now next we have to check whether the cylinder with greater volume also has greater surface area. So for this question I am going to find the surface area of both the cylinders. So now we will check whether the cylinder with greater volume also has greater surface area. So radius of cylinder A is half of the diameter, which is 7 by 2 centimeter, height is 14 centimeter and surface area formula is 2 pi r times r plus h. Now I'm going to put all the values over here. So it is 2 into 22 by 7. Radius is 7 by 2. Again radius is 7 by 2 plus 14. And if I'm going to reduce it, 2 and 2 cancel, 7 and 7 cancel. So it is 22 times. Now I'm going to take LCM over here. So 7 plus 28 and 7 plus 28 is 35 by 2 and if I reduce it, it is 11 and 11 into 35 is 385 centimeter square. Now we will find the surface area of cylinder B. So radius is again half of diameter. So 14 divided by 2 is 7, height is 7. Again I am going to put all the values in the surface area formula. So it is 2 into 22 by 7. Radius is also 7 and height is also 7. So from here we will get 44 into 7 plus 7 which will give me 14 and if I multiply I will get 616 centimeter square. So in this case also surface area of cylinder B is greater than the surface area of cylinder A. And we have seen that volume was also greater for cylinder B. So from here I can say that yes, cylinder with greater volume has greater surface area. Okay. So question number 3, find the height of a cuboid whose base area is 180 centimeter square and volume is 900 centimeter cube. So here base area and volume is given, and we know that volume of a cuboid formula is length into breadth into height. But another formula is volume of a cuboid is base area into height. So I am going to use the another formula because here base area and volume both is given, right? So base area is given as 180 centimeter square, volume of a cuboid is 900 centimeter cube, and we know that volume of a cuboid, another formula is base area into height. So now I'm going to put all the values over here. So my base area is 180, height I can assume as h, and volume is 900. So if I'm going to transpose 180 to the other side, I will get 900 by 180, and 90 divided by 18 is 5. So it is height of the cuboid is 5 centimeter. This was a simple question. Now moving to the next question. Question number 4. A cuboid is of dimension 60 centimeter into 54 centimeter into 30 centimeter. It means length is 60, breadth is 54, height is 30. How many small cubes with side 6 centimeter can be placed in the given cuboid? So in this question, what it says, there is a cuboid, okay? There is a big cuboid. Inside you have to place small cubes, isn't it? You have to find how many cubes can fill this cuboid. So can I say from here the volume of the cuboid will be equal to the volume of all these small cubes, right? But I don't know how many small cubes will fit inside this cuboid. So I have to find the number of cubes. So to find that, we have to first find the volume of the cuboid, then we will find the volume of the small cube also. Okay, so let's find the volume first. So length, breadth and height of the cuboid is given. Volume of the cuboid formula is length into breadth into height. And if I am going to put all the values, it is 60 into 54 into 30. And if I am going to multiply it, I will get 97,200 centimeter cube. So this is the volume of the cuboid. Now each side of a cube is 6 centimeter. So volume of a cube is side into side into side, which will give me 6 into 6 into 6, which is 216 centimeter cube, right? Now to find the number of cubes, from here I can say that the volume of this cuboid is equal to the sum of the volume of all the cubes, but I don't know how many cubes it can fit inside. So I will assume let the number of cubes is n. So from here can I write n into volume of one cube will be equal to volume of the cuboid, right? Because you are going to place the cubes inside the cuboid, so volume must be same. And from here you can, if you have to find the number of small cubes, so it will be volume of cuboid divided by volume of cube, isn't it? You have to find the number of cubes. So what I did, I have transposed this volume to the other side. So it multiplication became division. So now to find the number of small cubes, we have the volume of cuboid as well as cube. So let's put the values over here. So volume of the cuboid is 97,200 and volume of a cube is 216. And if I'm going to reduce it, 6 table, 6 times 36, and here I will get 6 times 100, 16200, again 6 times 6, again 6 times 2700, and again if I do using 6 table, I will get 6 times 450. So 450 small cubes can be placed in the cuboid. Okay. Question number 5. Find the height of the cylinder whose volume is 1.54 meter cube and the diameter of the base is 140 centimeter. So volume is given, diameter is given. But you have to be very careful. Volume is given in meter cube, diameter is given in centimeter, right? So you have to convert and make it in the same unit. So let's write what and all is given in the question. So diameter is 140 centimeter. So radius will be half of the diameter, 70 centimeter. I'm going to convert that 7 centimeter to meters. I have to divide by 100. So if I reduce it, I will get 7 by 10 meters. So from here I can say my radius is 7 by 10 meter. Now next is, I am going to assume let my height of the cylinder be h. and volume is given as 1.54 meter cube, right? And this is the formula, pi r square h equal to 1.54. Now I know the value of pi, I know the value of radius also. So from here I can calculate the height. So 22 by 7 into radius is 7 by 10. So 7 by 10 into height equal to 1.54. Now 7 and 7 I can reduce. So from here I am getting 22 into 7 into h. Okay. And 10 into 10, 100, I am transposing it to the right hand side. So it will be 1.54 into 100, and 22 into 7 is also 154. So if I multiply 1.54 into 100, I will get 154. So from here, if I calculate, my height will be 154 divided by 154, which will give me 1 meter. So the height of the cylinder is 1 meter. Now question number 6. A milk tank is in the form of a cylinder whose radius is 1.5 meter and length is 7 meter. Find the quantity of milk in liters that can be stored in the tank. So you have to find how much liter of milk it can store. It means you have to find the volume, capacity of the tank, isn't it? Now here if you find the volume, radius and length both is given in meter, but you have to give answer in liters, right? So we have a relation, 1 meter cube is 1000 liter. So first I'll get the volume, in meter cube, and then I'm going to convert it into liters. Now if you see this question here, length is given as 7 meter, means this length is 7 meter. Okay, now if I keep this cylinder like this, that cylinder is in horizontal position. Now if I keep this cylinder like this length will become my height. So from here you can say the height of the cylinder is 7 meter. So let's write what and all is given in the question. Radius is 1.5 meter, height is 7 meter. Now volume formula is pi r square h. From here if I am going to substitute the values, it is 22 by 7 into 1.5 into 1.5 into 7. Now 7 and 7 I can reduce. So it is 22 into 1.5 into 1.5. I know it is 2.25, and if I'm going to multiply it, I will get 49.5 meter cube. But I have to give my answer in liters. So I know that 1 meter cube is 1000 liter. So I have to multiply 49.5 with 1000, and this will give my answer in liters. So it will be 49,500 liters. So the quantity of milk in the liter will be quantity of the milk in liters will be 49,500. Now question number 7. If each edge of a cube is doubled, how many times will its surface area increase? How many times will its volume increase? So here, the first you have to consider the original cube. Let the edge of the original cube be A. Now from A, what is happening? The cube is doubled, isn't it? The edge of the cube is doubled. So A becomes 2A. Double means twice of it. So it becomes 2A. Now, so I am going to find the surface area and volume for both the cases of the original cube, and when the edge of the cube is doubled, then what is the surface area and volume. Then I will find out how many times surface area and volume increases. Okay. So let the edge of the original cube be A. So from here I can write volume as A cube, and I have considered it as V1. Surface area formula is 6A square, and I have denoted it as SA1. Now the edge of the new cube is doubled, so it became 2A. So volume will be 2A whole cube. Now many children do mistake, they just write 2A cube. It is not 2A cube, it is 2A whole cube. So 2 cube is 8 and A cube is A cube. So it is 8A cube. Same way, now surface area is 6A square. Now your A is 2A. So it is 6 into 4A square. So 6 fours are 24A square. Now to find how many times it increases, you have to find the ratio, isn't it? We have studied in comparing quantities, right? So the ratio is also a way of comparison by division, and it will tell how many times something is more, isn't it? So let's find the ratio. First for surface area I will find out. So from here if you see SA2 by SA1. So surface area of second one is 24A square and surface area of first one is 6A square. And if I simplify, I will get 4 by 1. And if I'm going to cross multiply it, I will get surface area of second is 4 times the surface area of first. So from here I can write surface area increases by 4 times. Can you see here? 4 times the original surface area. Similarly, let's find the volume. So volume of the second, the cube of where the size is doubled. So the volume is 8a cube and the original is a cube. So a cube and a cube I can cancel. It will be 8 by 1. And again, if I cross multiply, the volume is 8 times the original volume, isn't it? So the volume increases by 8 times. Now this type of question is important. It may come in 2 marks. So please practice these type of questions, important for exam point of view. Now let's move to last question. Question number 8. Water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. So rate is given in 1 minute. 60 liter of water is pouring in the reservoir. If the volume of the reservoir is 108 meter cube, find the number of hours it will take to fill the reservoir. Now see, volume is given in meter cube, but rate is given in liters per minute. So what I will do, I'll convert the volume also in liter. And just now we have seen, we know the relation 1 meter cube is 1000 liter, right? So volume of the reservoir in liters will be 108 into 1000. Now the rate which is given over here, it tells that in 1 minute water filled in the reservoir is 60 liters. And what you have to find? Number of hours. You have to give answer in hours, not in minute. And we know that 60 minutes in 1 hour. So we know that here in 1 minute water filled in the reservoir is 60 liters. So let's find in 60 minutes how much it can fill. So in 60 minutes it will fill 60 into 60, which is 3600 liters. And 60 minutes means 1 hour. So in 1 hour 3600 liters of water can be poured in the reservoir. So how much time it will take to pour 1,08,000 liters of water? So to find out number of hours, you have to divide the complete volume of the reservoir with the water filled in the reservoir in 1 hour. Okay, so time taken to fill 1,08,000 liters of water will be 1,08,000 divided by 3,600. So if I'm going to reduce it, so it is 1080 by 36, and 36 times 3 is 108, so it is 30. So it will take 30 hours, isn't it? So it will take 30 hours to fill the reservoir. So that's all for today's class. Now I've completed this mensuration chapter, and if you have any doubt, you can put it up in the comment box. And if you like my content, please share with your friends and subscribe my channel as much as possible. Thank you.